Hello guys, welcome back to Foolish Engineers videos. Have you ever noticed the whole world is very bullish on renewable energy like wind energy and solar energy. Many countries like India and China are also heavily investing in these technologies. Out of those, solar energy is considered more efficient and easy to use. Today, we are going to see what kind of electronics goes behind it, and if you watch till the end, there's something amazing that I want to share with you. So, stick around. Before going into the concepts, I would like to mention today's sponsors. This video is made possible because of Texas Instruments. They are pioneers of semiconductor world. They make those tiny ICs which we see in the circuit boards. We'll see more about it at the end of the video. We already know using solar panels, we can convert solar energy into electrical energy. We can simply install these solar panels on the roof of our home and theoretically we'll get unlimited renewable energy. We use multiple small solar panels to create a full setup on the roof. But it is not that straightforward. There are many challenges to it. Very first is that the solar panels generate DC power and our home appliances work on AC supply which you get from the grid. And the voltage generated by these solar panels is never constant. It depends on the sun's light and heat. So this parameter is never constant throughout the day. Well, to mitigate all of these problems, we have to take the help of power electronics which will provide maximum power out of these solar panels and convert this DC power into AC. For this job, we use different type of inverters which are called solar inverters. Solar inverter converts DC power into smooth AC so that we can use our appliances at home easily. Also, it tracks maximum power which can be extracted from the solar panels. And if there is excessive energy, we can give it back to the electrical grid so that we can earn more money from the setup. It requires complex hardware and power electronics logic. So, a normal circuit first converts this unregulated DC voltage into constant DC using a DC to DC converter, which we have seen in many of our older videos. Once we get DC, then it converts this DC supply into AC power using an inverter. There are many different setups on how these panels and inverters work together. But in this video, we'll see bidirectional micro inverter based setup. In this setup, we connect a DC to DC converter to each solar panel which will provide constant DC and maximum power out of this solar panel. We stack all of these units together and give it to a common inverter which converts DC power into AC. Now, this is how the inverter circuit looks like. There are so many components and it looks a bit complicated as well. Let's make it easy and divide them into smaller blocks. First, we have solar cells. Let's consider it produces voltage between 30 volts to 60 volts DC, and this will get converted into constant 75 volts DC. And there will be multiple solar panels and DC to DC converter which are stacked together. Now, we cannot directly convert this DC power into AC supply. So here we will do one more DC to DC converter which will convert this 75 volts DC to 400 volts. The main advantage of this part is to give higher voltage for AC conversion and provide isolation between input and output. Next block is the real inverter and it converts 400 volts DC into 230 volts AC power which powers our household appliances. Let's name these blocks A, B and C. This circuit is a bidirectional converter which flows the power in both directions. For example, instead of solar panels, we can simply connect battery packs to store charge from the grid. Here, This block can convert 230 volts AC to 400 volt DC using the same inverter circuit. Then this stage can convert 400 volts to 75 volts DC from the DC to DC converter stage. And finally, this block can convert 75 volts DC into lower voltages if needed. The first block, which converts unregulated DC into regulated one, is a DC to DC converter block. As you can see, the input voltage might be around 30 volts to 60 volts DC, and we want to convert it into 75 volts DC. So a simple non-isolated DC to DC converter will be sufficient here. So we'll use synchronous boost converter for each solar panel. Apart from converting the DC voltage, this block gives efficient output from each panel using maximum power point tracking algorithm for solar panels. So it consists of mainly two FETs, an inductor, voltage and current source for feedback control circuitry, etc. So if the power transfers from block A to B, it works as a boost converter which steps up the voltage using this configuration. And when the power transfers from B to A, this block will work as synchronous buck converter using this configuration. And it will simply step down the voltage.